All right, good evening, everyone. It's 8 o'clock, so we'll go ahead and get started. So the material for this week was a lot about how to do different kind of loops and some things that we can do with loops. For example, counting, summing, finding the largest and smallest values, and yeah, that's pretty much it. So let's go ahead and start looking at some. Actually, the first thing is updating variables. Uh, Really, this should be pretty self-explanatory. You should have been doing some of this up to this point anyway. Uh, my screen's a little bit frozen. It may take a second. Let me see. All right, I'm gonna pause for like 1 minute or so. My screen's frozen and I'll have to get it unfrozen. Just give me a second. All right, you all should be able to see this screen now. So let me bring up Notepad. The screen sharing is not wanting to cooperate today. Just have that down there. Chat over there. Okay, so let's get started for real this time. So the first topic, of course, like I had started with, is updating of variables. Now we've been using a lot of variables throughout the class so far, and updating variables is something we've already been doing. We just may not have used the exact terminology of updating variables. For example, so if we have a variable that's a, we'll make it equal to 1. Let's just print that out, a. Let me save this on my desktop as file.py. Bring up the command window. Of course, if we run it, let me see if I can make this text bigger for us. There we go, font, make it bigger, 36. That's really big, but that works. A little bit too big. I apologize for this. The screen sharing was messing up a little bit earlier and threw me a little bit off. There we go. That should be fine. So we have a variable called a, and we assigned the value 1. So right off the bat, it has the value 1, right? Well, and of course we print it out and we get the value 1. So when we say we update a variable, that means after we've already established the value of a variable, we can change it to whatever we want. We can say a equals a plus 1, right? If we print that out, again, print out the a, of course a should be 2, right? Run it. Sure enough, it prints out the 1 and then it prints out the 2. All that's meaning is we've changed the value of the variable. That's all we mean when we say updating variables, is you initially assign a value to a variable and then you update the variable with a new value. And it doesn't have to be a plus 1, it could be 4 plus 1, right? Or we could have b equals 3, and then here we have b plus 1, right? All we're saying is that we're changing the value of the variable. At first it was 1, and here we are modifying the value of the variable to be a new expression. In this case, b plus 1. Of course, if we save and run that, we'll get the expected value of 4. Okay. So that's what we mean when we say updating a variable. So now let's talk about the loops. So the first loop we have is the while. Well, first of all, let's talk about what a loop is. A loop is a situation in your code in which you want to execute the same pieces of code over and over and over repeatedly until some certain condition is met. So if we have, let's say for instance, we want the user to input some numbers, right? How would we do that? We'll say a equals, let's make an integer input, enter a number, right? And then we'll just print a. So if we run this, we'll get, of course, expect exactly what we think. It says enter a number, we enter the number 12, and then it just prints out 12. Well, what if we had a situation in which we wanted the user to input a number a bunch of times, right? Well, let's say if we wanted them to input it 3 times, we could do this, right? Let's just say 4 times. So what will this code do? This code will ask the user to input a number 4 times, right? Let's save it. Let's run it. It does what we expect to, move this out of the way, 3, 4, and then it stops, right? Okay, that's not so bad. What if we wanted the user to input 10 numbers, right? Are we going to copy and paste the same piece of code 10 times? No, that doesn't make a lot of sense. So that's where we run to a situation of using a loop. And the first loop it talks about in the course content is a while loop. What this means is while, this is going to be pseudocode right here, while a condition is true, then we want to run this code, run this code, run this code, run this code. And we can have as many of these statements run this code as we want. Like this could be enter a number. This might be enter a number. This might be enter a second number. This might be add the 2 numbers together. This might be print the result out, right? And what will happen is this piece of code will run basically forever until this condition is false. Once this condition is false, then it starts executing after the while loop. And what do I mean by a condition? It is something that can either be true or false. Well, in Python, we actually have a keyword called true. Now, if we have this keyword true, this is a condition. Is this true? Is it true or is it false? So what our code will get to, it'll get to this loop that starts with a while. It'll say, is this true? In this case, it is true because true is true. So if this is true, all of this code will be executed. So let's use the adding two numbers example. Say a equals, it's an integer, input, enter a number. We'll do the same thing for b. Enter another number. Excuse me, let's make that b. I'm having problems today. Then we'll say c equals a plus b, and then we will print c. Okay. So let's save this. Let's think about it for a second, and then we'll run it. So the Python code gets to this loop. It says, is this true or is this false? If this is true, it will execute all these statements. Then it'll loop back up here to the top of the loop, and then it'll ask the question again. Is this true? If it's true, it'll execute all these statements. It'll come back to the top of the loop and ask again, is this true? Since we're using just the word true, then this is always true. So it'll always loop forever and ever and ever. It will keep looping until this is false. It'll ask, is this true or false? If it is false, it will skip all of these statements. And then it'll go down here after the while loop. We'll put that text, we'll put this printout here so that we know once we've gotten after the loop. Okay. But right now, let's put true because I want it to execute these statements in here. So let's save it. Let's run it. So it says enter a number, put 1, enter another number 2. It prints out the answer of 3 as we expected. I'll make this a little bit bigger for you there. 28, that's probably good. Yeah, that looks better. And then it goes back to the top of the loop. So as you can see here, we said enter a number. So we know it's here, enter a number. Then it says enter another number. Then it added them together and then it printed the result. And that's the first 3 lines that we see in the program. Then the next line we see is enter a number. So what has happened is it's went back to the top of this while loop and said, is this true or false? It is true. So it starts executing these statements again. And what you see right here is I have this indentation, right? Note, these are not spaces. This is a tab key. This is not spaces. And tabs are actually very important in Python. It helps to delineate when the beginning of a loop begins and ends. So as you can see here, I have this while loop, and the statements that are part of the loop, they're all tabbed in one space. Once we no longer tab in, that means this code is outside. It is after the while loop. That is the significance of these tabs right here. Okay, so we're back to the top of the loop. Let's enter a number. Let's try to get it all on the screen at the same time. There we go. So enter a number, we enter 2 and 3. Your press result is 5. It asks me to enter a number again, 4 and 5, press the result. As you can see, it keeps repeating the same code over and over and over. Now, as I said, it'll keep going until this condition is false. Well, right now, this will never be false. And you know, in this example I have here, and the reason being is I specifically use the word true. And this is a specific Python word. So this will always be true. This loop will always execute, and it'll never end. This is actually what we call an infinite loop. meaning once our program gets into this loop, it will never get out of the loop. And that's because every time it does this check on this condition is always true. So how can we do better? Let's say we have a variable called I, and we start it to be 0, right? Well, for this condition, we don't just have the words true and false. We can have mathematical comparisons. We could say while I is equal to 0. That means as long as this variable I is equal to 0, we'll do the loop. As soon as I is not 0, it'll break out of the loop. So we can have equal, and note I use two equal symbols here. When you're comparing a variable and a value, for comparison you use the double equal signs. It's just a programming thing. It's the true in pretty much every programming language. So if you make that mistake and just use a single equals, actually I think it gives you an error. If it doesn't give you an error, it certainly won't do what you think it does. So make sure you use double equals. But we don't have to use equals. We can say while I is less than 0, while I is less than or equal to 0. You know, we got greater than. We got greater than or equal to. We have not equal to. So let's say while I is less than, say, 3. Okay. So if we run this as it is, you know, how many times is this going to execute? Let's break out of this. There we go. So how many times will this execute like we have it now? It's actually still an infinite loop. And why is that? Okay, let's examine it. So I starts off being 0. Now we're saying while, and this is the condition, is I less than 3? Well, I is 0, so this is true. 0 is less than 3. So we'll go through here and perform all these statements. It'll come back to the top of this loop. It'll make this comparison again. Is I less than 3? Well, I is still 0. 0 is less than 3. That is true. It'll do the loop. So how do we get it to stop doing the loop? Well, as soon as we assign I any value that is not less than 3. So if we do this, what will happen? I is 0. 0 less than 3. That is true. We'll come through and do this. Now we're going to say I is equal to 3. All right, let's come back up here. 3 less than 3. That is false. 3 is not less than 3. So because this is now false, it will skip the loop. It'll skip all this and come down to the statements after the loop. So let's see it do it a few times. So instead of sending it to 3, let's just say I equals I plus 1. What will happen here? And we'll also print out C. We'll also print out what the value of I is, just so we can see what's going on. All right, let's run this. So enter two numbers. It sums them up to be 3. I is 1. So since 1 is less than 3, it keeps going. Let's put 3 and 4. It sums them up. I is now 2. 2 is less than 3. That's true. So let's 4 and 5. Look what happened now. We're after the while loop. And that's because on that last iteration, I was now 3. And so it made the comparison. Is 3 less than 3? The answer is false. So it did not ask us to input any more numbers. And it skipped right here to after the while loop. So that's how a while loop works. Is you use the keyword while. You give it some kind of condition here that can be true or false. It can be the word true, which will make it an infinite loop. It'll never stop because true is always true. You could use the word false, But since false is always false, you will never do any of these statements in here. So the most useful thing really is a mathematical comparison. And in our example, we did I less than 3. And so what that did is it ensured that this loop was executed 3 times. So that's what the while loop looks like. The other loops are very similar. We already talked about infinite loops. Let's talk about, we'll do for loops. So there's several different ways you can do a for loop, okay? So the easiest example of this is, let's make a list of names. And I believe we've done this in assignments before. So let's make a list of names. Dan, Joe, Cindy, Carrie, Carrie. All right, so we have this list of names. Let's delete all this stuff. So and then let's just print out the names right now. So if we just print out the names, it's just going to give us all the names in one long list, right? If we run it, print it out, as you see, it prints out the whole list of names all together, right? Dan, Joe, Cindy, Carrie, right? Okay. What happens if we want to do one name at a time? For example, maybe we want to know how much each person weighs, right? And so we could have the user input on the keyboard the weight for each of these individuals, right? So how would we do something like that? How would we go through each name one at a time? We could use a while loop. It's a little more complicated, but it's complicated for this example. The easiest way, though, is with a for loop. And let's look at what the for loop looks like. Start with keyword for. Then you use a variable. You can use any name for the variable you want. I'm going to say in. Then you use the word in and the name of the list. Starts off being like that. So what you're saying here is, in this loop, I'm going to have a variable named in. I am looping through this list of names, meaning this is the list that I am looping through. What's going to happen is, the first time in the loop, in will be Dan. The second time in the loop, in will be Joe. The third time, in will be Cindy, and the fourth time, in will be Carrie. And it knows to stop it after 4 times because that's how many things are in this list. So right now, let's just print out what in is. Let's save it. And if we run it, it should print out those names, but instead of looking like this as an entire list, it should just print them out one at a time on individual lines. Let's run it. Sure enough, there you go. You get Dan, Joe, Cindy, and Carrie, right? One at a time, because in was each of those names independently one at a time. And the good thing about this is we can add to it. Josh, I don't know. Okay. But I didn't have to, even though I changed how many things were in my list, I didn't have to actually change my loop, because using the for loop like this, by saying in names, Python knows how many items are in this list. And so it knows how many times to loop. So if we save and run this, you see I have Josh added onto the end. Likewise, I can remove items. Save it and run it. And same thing. It just loops through the 3 individuals, right? So how does that help the example? Like I said, maybe we want to enter the weight for each individual, right? So let's do weight equals the integer input weight. Yep. And then we'll just print out the W. Let's just try that. So we'll be entering the weight for each of these 3 individuals. We'll loop this many times in this example 3 times, and each time we'll ask for, to enter the weight. Okay, let's see. Let's run that. Weight 20, 30, 40, whatever. And then we just printed out the weight. Well, wouldn't this make more sense if we say printed the name of the individual that you're entering the weight for? Because the end user of your program isn't going to be looking at your source code, right? They will be looking at this prompt to use. So if you just run this prompt, enter weight. Well, whose weight am I entering? Was it Dan, Joe, Cindy, or was it Cindy, Joe, Dan, or was it Cindy, Dan, Joe? What order was it in? I don't remember. So what you can do is let's tell it whose weight to print out. So we can input N plus weight. And remember what N is. N is this string Dan. Next time the loop, N is the string Joe, and so on and so forth. So what we're doing for our prompt is we're saying the name of the individual and then followed by weight as the prompt. So let's save it and run it. And sure enough, we're asking for Dan's weight, 30. We're asking for Joe's weight, 40. We're asking for Cindy's weight, 50. And then it ends because it knows that we have 3 items. Okay. So that's one way you can do the for loop. That is useful if you do not wish to modify what is in these names. Meaning, for my example, I'm only using N to print it out, right? I'm not trying to change what N is. If you want to change what's in the list, we need to use a different for loop. But this one is useful if you just want to go through a list, but you don't want to modify that list. So let's take a look at another example, another for loop where you would want to modify the list. So let's change, instead let's change these to numbers. 1, 2, 3, 4, 5, 6. All right. And we're not going to use this for loop anymore. We're going to use a different for loop. So the other kind of for loop, it looks kind of the same. For, use a variable name. I almost always like to use I for this, and you'll see why in a minute. For I, also N. But here we need to tell it how many items are in the list. We have what's called the range keyword. And then inside these parentheses, we need to tell it how many items are in the list. For our names, it's not really names anymore. Let's call it numbers now, because it's numbers. So how many numbers are in this list? 1, 2, 3, 4, 5, 6. So there's 6 numbers in this list. And I'm not talking about the highest number. That's just a coincidence, of course. It's how many numbers are in the list. Okay. So we have this for loop with for I in range 6. With 6 being how many items are in the list. So let's print out, let me change these numbers around a little bit because it'll get confusing if we don't, and you'll see why. Let's just say 19, 32, 33, 24, 15, 15, and 96. I don't know. All right. So let's print. What do we want to print? So just like the previous loop where we had for N in names, N was each consecutive string that was the person's name. I is not this number. I is not 19. I is not 32. I is not 33. Well, then how does that help us? What is I? So let's just print I. Let's save it and let's run it. As you can see, I is the numbers 0, 1, 2, 3, 4, and 5. So what is I? I is basically a counter that starts at 0 and goes up to this number minus 1. So if you see, I started at 0 and the last I value was 5. That's all this is doing, is basically counting I from 0 up to this number minus 1. So how can we use that to access this numbers list? We have what we call an index. And that's why I use the I here. You could just spell out index. I use I to stand for index. It doesn't have to be I. You can call it ASDF. It doesn't matter what you call that variable name, but I like to use I. So how can we print out each of these numbers in here? We have what we call, like I said, we'll call it index. We have this numbers list. Then we have these square brackets. Inside these square brackets, we put the index of the number that we want to access. And what does that mean? Index is what place in this list is that number located. And for Python and pretty much every programming languages, indexes always start at 0. So this is index 0. This is index 1. This is index 2. This is index 3, index 4, and index 5. Well, we've already seen that our I value goes from 0 to 5. Oh, well, what a coincidence. Our numbers in our list go from indexes 0 to 5. So we can access the actual number like this, the name of the list, numbers, and then inside the square brackets, we put the index we want to access. And since I is counting from 0 to 5, this will access all the numbers from index 0 to index 5. And it just prints them out. So let's save it and let's run it. And sure enough, there you go. We're printing out all of those numbers, 19, 32, and so on and so forth. So this right here was how we accessed each of those numbers. And here we were just printing it. So I said this for loop was best used if you want to modify the values of a list, right? Well, we can already see that numbers of I is how we access an individual item in this list. Well, we can do whatever we want with it. We can make it a new value. Let's make it, the value 2. Okay, let's take out the print, and at the end, we'll just print out the whole list at one time. So what we'll do is, and you'll see why this helps in our output. So we'll make this numbers list. We'll print out that list. Here, we are going to modify the list. And how? We're going to say the numbers at index 0 is now equal to 2. So instead of 19, it becomes 2. Then it loops again, it becomes index 1. We're going to change the numbers at index 1 to the value 2. And so on and so forth. It repeats. And then we'll print the list again. So you'll see, here is our list initially, right here. We have gone through and modified all of those values. And now we're printing out that list again. And you can see they've all been modified to 2. And it doesn't have to be just setting it to a specific number. We can say it's equal to, we're just going to double the value of all the numbers, right? The numbers at index I is equal to the numbers at index I times 2. That'll just double all the numbers, right? Save it and run it. And sure enough, you can see there, all of the numbers are now doubled. And the good thing about a list is you don't even have to, it doesn't even have to be numbers. It can be different types. I mean, we did strings previously with the names. All of these are numbers, but you can actually have numbers and letters together in the same list. Well, all right, so it changed them all to that string. Okay. Let's just do a little bit of fun. String I, what's that going to do? That's going to turn the index I into a string and add it onto ASDF. So you'll see like ASDF 0, ASDF 1, 2, 3, 4, and so on. And let's see that. We don't have anything else to do. And there you go, ASDF 0, 1, 2, 3, 4, 5, so on and so forth. So as you can see here, we have accessed the list. We have modified the value in the list. And we just print out the list again so we can see the modified values. So those are the 2 for loops. Okay. We also have counting loop. Counting loop is kind of easy. So let's go back to our names example. Names equals, actually, I do want to show you one more thing with this. Let me show you one more thing with this list. So, we had 4i in range of 6, with 6 being how many items are in this list, right? Okay. Well, what if we added another number? 6, I don't know. Let's save it and run it. Let me turn this back into doubling the numbers. Numbers I times 2. Save it and run it. As you can see, this is the initial list. This is the list after running through it. But look what happened. It didn't double that last number, right? Well, that makes sense because we only ran this many items in the list, 6. So 1, 2, 3, 4, 5, 6. This was the last one that it did, right? Well, okay, well, let's go in here, change this to 7, because there's 7 items in the list now. Save it, run it, and there it doubled it. Okay, I added another number. Save it, run it. Of course, it's not going to work right, of course. So, do we have to go in and manually change this number every time we change the size of the list? The answer is no. There is a built-in Python function called len. And what goes inside of len is, it stands for length. What do we want to get the length of? We want to get the length of the numbers list. So this length numbers will tell us how many items are in this list. So at this point, length of numbers is going to turn out to be, was like 8 items now. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. Length of numbers will now be 8. And so I will do the range up to 8. So that helps, right? Let's save it. Let's run it. As you can see, it now doubles all the numbers. Let's add another number. Save it. I don't have to modify my loop at all. Run it, and it doubled that number. I can reduce the amount of numbers, right? Save it and run it, and there we go. It works fine. So this is kind of the format you want to use with a for loop if you want to modify the items in a list. I mean, it doesn't always have to be a list. Let's talk about doing some sums, right? And that's actually another part of the content for this week is summing up some things. So my example is use number or use list, but we don't have to. We can do range, let's say up to 10. Let's do the sum of all numbers from 0 to 10. So let's have a variable called sum. We would do a loop that goes from, like I said, when we do this range, it does from 0 up to 1 minus this number. So it'll go from 0 to 9. So actually, if we wanted to sum from 0 to 10, we'd have to change this to 11. And that's because the last value of I is this number minus 1. So if we do this sum plus equals I, and then each time we'll print out what the sum is. And then at the very end, actually we don't need to do that at the very end. So let's save it. Let's run it. And there you go. It's first, that's 0 plus 0, that's 0 plus 1, then that's 1 plus 2, then that's, was it that plus 3, and then plus 4, plus 5, plus 6, and so on and so forth, right? So that's the sum of all the numbers from 0 to 10. So we did something useful with a loop without needing to use lists. So that's how you can do a sum, right? Yep, a summing loop right there. So let's talk about how to find the largest and smallest values. We'll do that with a loop. So let's go back. Let me see if I can undo to get my numbers list back. All right, bigger. All right, so I have this numbers loop, right? So how can we find the smallest value in this loop? Well, we can use the loop like this. It's actually, since we don't intend to modify the list, it's always easier to use this type of for loop if we don't intend to modify the list. Because all we want to do is just inspect each of the numbers. We want to know what each number is. We don't want to change what each number is. We want to find what the smallest one is. So how will we find the smallest? Well, at the end, we need to somehow print out what the smallest value is, right? But before we can print something out, we need to assign it a value. So at the beginning, let's give smallest a value. And we have in Python what we call none. What that means is smallest has no value. That is not 0. 0 is a value. So this is not 0. It just means it has no value. It's not a number, it's not a string, it's not a list, it's not 0. It is just no value. It has no value at all. Let's see what that looks like. See if we don't have this loop in here. If we just print this out with the smallest, it'll tell us smallest is none. It has no value. Okay, so let's put our loop back in there. So what we can do, so we have this value num. The first time through the loop, num is 19. And of course, as we saw earlier, it goes through all the values. So what we need to see is 19 the smallest number that we have seen so far. That's how it is in pseudocode. Is num the smallest value so far? If it is the smallest, then the smallest is num. Let me drag that back over a little bit. Yep, there we go. So that's kind of what it looks like in pseudocode. If you think about it, that makes sense. So is num the smallest value so far? And if it is the smallest, then the smallest is num. And that makes sense. The first time in the loop we have 19, we say, is 19 the smallest value so far? That is true. So the smallest value is 19. Then we go to num 32. Is 32 the smallest value so far? The answer is no, because we've seen 19. 33 is not the smallest. 24 is not the smallest. Then we get to 15. And we say, is 15 the smallest value so far? The answer is yes. So if it is the smallest, then the smallest is 15. So that's how that pseudocode works. So let's put that into Python. So if num is less than the smallest. Now, does that make sense? Is num the smallest value so far? So we already have the smallest value. Is num smaller than it? If it is, then the smallest equals num. Now there's one caveat to this. The first time in the loop, num is equal to 19. is 19, so when we get right here, if 19 less than none, that actually doesn't make sense. You can't compare a number to nothing. You can compare a number to a number, but you can't compare a number to nothing. And that's what we're doing here on the first time in the loop. We're going to say if 19 less than none, but that doesn't make sense. So we also need to check if smallest is already none. So we can say if smallest, oops, let me spell it right. If smallest is equal to none. Then we have or. Now, does this make sense? So the first time in the loop, smallest is none, num is 19. So we'll say if smallest is none, that is true, right? So because this is true, we don't even need to check that. This is already true. So since smallest is num, we say smallest is now equal to the number. Let's save it and run it. And we should get what? We should get 3 out of it, right? Save and run, of course there. And I'm right, of course. The answer is 3. Let's see what happens if we leave out that checking for the smallest is less, the none part. Let's run it. And we actually get an error. And why is that? You know, exactly like I said, you can't compare a number to nothing. And that's what it's saying. It's saying, you know, the less than is not supported between an integer and a none type, which is what the none is, nothing. So you have to keep that in there to see if the smallest is nothing. So that's how we can find the smallest value in a list. How do you think we can find the largest value in a list? It's actually really, really easy. So I'm not going to go through and change the variable names, but all I got to do is flip the sign around. That will give me the greatest value. Again, this less than will give me the smallest. If we do greater than, it'll give me the largest. So if we save it and run it, it should be 96, right? Yep. Let's run it. And sure enough, it gives me 96 as the answer. So that's how you can find the smallest and the largest values using a loop. Okay. That is pretty much all the content for this week. Let's take a quick look at what the assignment is, and then we'll open it up for questions. I believe the assignment is, remind yourself, yeah, you're computing the average grade for 5 students. Well, you're having the user input the grades for 5 students, and then you're going to compute the average of the 5 grades and the highest grade. Well, what a coincidence. I just showed you how to find the largest value, right? And then computing the average. So let's do something similar. Let's say we have some cars, right? Let's have a list of cars. A Ford, a Chevy, a Jeep, and a Honda. All right, I have a list of cars. Let's figure out let's ask the user to input how much each of them weigh. And let's get the average weight of all these cars, right? I'll get that done right. Oops. Okay, so start out, let's just print out the cars, make sure our loop is working, make sure that list is working. Run it. Oh, that's what I'm missing. I'm missing a quote mark there. There we go. I knew it looked funny. There we go. And of course, we got the list of different cars. So let's say we want the user to input how much each car weighs. Okay. Well, we've seen that we can do that with a for loop. We can loop through the number of times of items in the list. And we can do that with for C in cars. And of course, that'll loop through how many items are in this list, and C is equal to each of those strings one at a time. So let's have them input the weight. So let's say the weight is equal to, we want it to be an integer, and when I have them, for the prompt, we want it to be the name of the car, plus, yeah, actually my other example earlier did something like this, right? And then we'll just print out the weight. Okay. So this is something exactly like what we did earlier. Well, let's just run it. Let's do this slowly, one step at a time. So enter the weight of a Ford. It's 1,000 pounds. A Chevy weighs 2,000 pounds. A Jeep weighs 3,000 pounds. And a Honda weighs 4,000 pounds. Right? And that's the end of the program. Right? But like I said, we want to get the average weight of all the vehicles, right? Well, what do you need to compute the average? You need the total weight, and then you need to divide it by how many things you summed up right. So really it's a summing problem, right? We need to sum all the weights of all the cars. Well, just a few minutes ago, we did a loop about how to do a sum, right? So let's sum up all of these weights. The sum will start out with 0. Each time we put in a weight, we want to add that weight to the sum. Sum plus equals W. If you haven't read yet, the plus equals, that is just a shortcut for sum equals sum plus W. These two lines are exactly the same thing. This is just a shortcut for doing it. All right, so let's do that. And then after each time, we'll just print out the sum. All right. Let's see what happens. Ford weight, let's just say 10. So the sum so far is 10. Chevy weight is 20. Oops, I accidentally put 0. So the sum is still 10, plus 10 plus 0 is 0. Jeep weight is 30, so the sum is 40. The Honda weight is 50. So the sum of all the weights is 90 pounds, right? So let's print out the sum is plus the string of the sum, right? And let's take away this print sum here. So what this should do is after the loop, it should tell us the sum of all the weights. Save it and run it. 10, 20, 30, 40. The sum is 100 pounds. Okay. What's the average weight? Well, the average, I'm not teaching a math class, so average should be pretty simple. The average is the sum divided by, how many things that you summed up. For our example, we summed up 4 things. So let's print the average. We'll say average is string of the AVG. There we go. Let's save it and run it. Let's get 10, 20, 30, 40. So the sum is 100 pounds and the average is 25, and that makes sense. All right, what happens if we add another car? What else is there? There's a Volkswagen, right? Save it and run it. I hope somebody out there has seen what's getting ready to go wrong. So it's 10 pounds, 20 pounds, 30 pounds, 40 pounds. There's our VW weight. So the sum is 150, the average is 37.5. Is that right? It's not right, is it? And this is where your test cases should help you if you make this mistake. So what should the average be? Let's run our calculator. So we said 10 plus 20 plus 30 plus 40 plus 50. And we have 1, 2, 3, 4, 5 cars. The average should be 30 pounds, right? So the average should be 30, but my program is telling me the average is 37.5. So that's a good indication of where a test case can help you out. So I've done something wrong in my programming. It's actually right here where I compute the average. I say the average is the sum divided by 4. Well, that worked when I had only 4 cars, but now I have 5 cars. So this is a good place to put what I showed you in one of the for loops. We can put the length of cars. And in this case, this right here will end up being 5. Why? Because we have 5 cars. And so that's the right way to compute the average. Save it and run it. 10, 20, 30, 40, 50. There we go. The average is 30. I manually computed the average as 30. Test case passes. My program is correct. You know, it works if we reduce the number of items in the cars list. Save. 100 pounds, 150 pounds, 200 pounds. Well, I mistyped in the forward weight based on what I said. Is that the right answer? 10 plus 150 plus 200. So the sum is 360. That's right. The average should be 120, and that's right. So I knew I did the program right. So this is actually very similar to what you should be doing for your homework assignment. Of course, you need to adapt it to what the assignment says. One other thing about the assignments, and then I'll open it for questions, is we're still having problems with individuals doing the test report correctly. Please look back at the content 3 test cases, and please use that content, what goes into a test case, and that format. So please do that. So unless, actually I'll go ahead and open it up for questions now.
Hey, good evening, Professor.
Yep, go ahead.
So just going back, so to get the, like the highest of the weight, again, we would need to include the len on the outside of the variable to make sure that we include all 5 of the, the car names or whatever variables you're comparing.
Do you mean right here with this sum, how I've done this? Or if
Yes,
you're,
yeah, because when I was running it, I guess it wasn't including all 5 of the the inputted variables. It was only looking at the first 4. I
yeah,
think because the first variable counts as 0.
yeah, that's correct. When you do this, the length, this length tells you how many items are in here. So that way, in this case, let's throw away the rest of this. Let's just do the length of cars here, right? So if we save it and we run that, we will see. I'm not going to type, actually, just save it. Oh, I need to print the length, right? Print the length of the cars. Save it. And you see it's 3, right? I'm not going to input the rest of the stuff. If we add more items here, a car A, car B, we save that and run that. Of course, it tells us the number of items in there are 5. And since when we do this kind of loop, it automatically knows to go through every single item in here. That means it'll do this loop 5 times. So at the end, when we're computing the average, the average, you need to divide the total sum divided by how many things that you summed up together. And since we summed up all of these items, well, we summed up their weight that was input. That's how many times we need to divide. So that's why I use the length of the cars there. Again, for this list, I could manually put the number 5, and that would work as long as this list did not change. But as soon as I add or remove an item from here, I would either have to go change that number, or so I don't ever have to worry about it again, I can just put the length of that list. Like I said, you could just leave the number, but then if your list ever changes size, this is going to give you the wrong answer, right? So that's why it's encouraged to use the length of the list there. So if your list ever changes, you don't have to worry about the math part down here.
Gotcha. Okay, thank you.
Hey, Professor Brian Newton here. Can you hear me?
Yep.
I just wanted to make sure. I noticed that I think I did things just a little different for this week. I just want to make sure if we get to the right answer and we follow all the requirements of the assignment that we're good to go. Like I used, I put my stuff into another list and kind of did the sum of that list over the length of that list. Is that all right?
Yep. That's we haven't got into appending to a list and stuff like that yet. That's actually in future weeks. I have no problem if you do that. If you get to the right answer that way, that's perfectly fine. As long as you're following the specifications in the assignment. For example, the assignment just says, have a list of students, print out their names, input their weights, get the sum of their weight, or get the average of their, sorry, I'm still saying weight. It's talking about quiz grades for the students. So it's asking you, to input the quiz grade, display the average of the quiz grade and the highest quiz grade. So if you want to make a new list and you put the quiz grades in that list, there's nothing wrong with doing it that way.
Okay, that was all I had. Thank you.
Professor, my second question, so going off of the example that you have posted right now of the different car names, so your list includes, the 3 car names, Ford, Chevy, and Jeep. And then let's say you had the 4 loop that, requires the user to input the weight of each vehicle. How would you pull the input of that weight to determine like the minimum, the smallest or the highest weight, or really to compare, the variables that are inputted for each of those, the cars in that list?
Okay. So let's throw out this sum and stuff right now. We don't want to do the sum anymore. Let's say we want to find the smallest weight. Well, earlier we did an example of finding the smallest value in a list of numbers, right? It's pretty much the same concept. So if we want to find the smallest weight, we need to keep a variable called smallest. Initially, it has no value. Then inside the loop, we ask for the weight. Now we need to ask ourselves, and we'll do pseudocode just like we did earlier, is weight the smallest weight so far? If it is, then this weight, or then the smallest is this weight, right? Move this back out of the way. There we go. Right. So it's the same concept with the same pseudocode, kind of the same example we did earlier. So let's make this into Python. So this is where we had if the smallest is equal to none, and I went over earlier why that's important, making that check, or if this new weight is less than the smallest, then the smallest is this weight. And then at the end, let's print out the smallest to make sure it's right. So let's think about it for a second. So we'll loop through how many ever times. Right now, let's delete these off here so we just have 3 cars to worry about, just to make it a little bit shorter. Let's remove this print because we don't need it. Okay, so we're going to enter the weight for each of these cars. Now we're going to say if the smallest is the none value, meaning we haven't got any smallest value yet, or if this inputted weight is less than the smallest one we've seen so far, then the smallest is equal to this new weight. So if we run this, oops. Let's run this. Ford weighs 1,000, Chevy weighs 2,000, and Jeep weighs 50 pounds, and whatever. And sure enough, there at the end, it says 50 is the smallest weight that was input in this list. So that's how you can find the smallest. For the largest, it's as easy as flipping around that sign. So instead of less than, we can call it greater than. Ideally, you'd want to go through and change this from smallest to greatest, so that the program, if you're reading it, it makes sense. But I'm not going to go through and change the name of it right now. So let's save it and let's run it. And let's enter the same values. And sure enough, it has 2,000 as the greatest weight. So that's how you can find the smallest or the largest value that was input inside one of these loops. The key is that you have to have, whatever you're trying to find, you have to initialize it before with a none value. Then you do these comparisons in here. And then after the loop, you have either the smallest or the largest, whichever you were looking for.
Awesome, thank you. Yeah, I guess I was trying to compute the average and the highest or the lowest, variable in a separate for loop. But I see how it works better if you nest it within, the same for loop.
Okay. All right, I will, not much heard right now. I'll stick around for a couple more minutes. If you have a question, go ahead and ask it. If not, you can feel free to drop off whenever you like. The session is being recorded and I will get it uploaded sometime later tonight or first thing in the morning, and I'll get the link emailed out.
All right, thank you, Professor. I'm signing off.